Homework 4.1, Exponential Functions, Video 3. Homework due Friday, May 29th at 11:59 p.m. You'll notice that I've summarized most of the exponent rules in this column here, except for the two things that we can't do, which is distribute powers across addition and across subtraction. Also, the following video is associated with questions 1 through 5 in your homework. Before we get to graphing, we're going to talk about using a calculator to evaluate exponential functions. You're going to need a calculator that is not only capable of handling powers, or exponents, but they must also have another button, and I'm going to show you what the button looks like. Your calculator must have a button that says LN and a button that says log. And they're usually pretty easy to spot. Log, LN. Now, for the duration of this video and throughout the next few videos, I will be referring to calculators as either display calculators or one-line calculators. A display calculator, get the focus going here, is a calculator that can and will display whatever you type. For example, you might have noticed that the first problem on the board says, come on, focus, 5 to the 1.7 power. If I type 5 to the 1.7 power in here, here's the 5. The calculator's off. Let's turn it back on. Clear that out. All right, so I'm not going to show you where the 5 is. You know where 5 is. 5. Now, it's your responsibility to know where your exponent button is. It may look like this one by my left thumb. It looks like an arrow pointing up. In other calculators, it'll look different. I'll show you in the other one in a second. If you have a TI graphing calculator, then it looks like that, but it's above the division button. Exponent, and then press 1.7. But a display calculator will display the problem before it gives you the answer, and then you press equals or enter, and there's your answer. But a one-line calculator, or a non-display calculator, will only show you, let me put it in degree mode, we're not doing trigonometry, but that's bothering me. A one-line calculator will only show you either the last number you typed in or the last answer it gave you. So if I wanted to do 5 to the 1.7 power on this calculator, the exponent button says y to the x. So I would have to press 5 and then the exponent button and then 1.7. And if you'll notice, I don't see the whole problem. I just see the last number I typed in. And then I have to press equals to complete the operation. And I got the same answer as before. 15.42584657. Now your calculator may show more or less digits, but the homework's going to ask you to round to 3 decimal places. So just a quick review about rounding. I'm going to write everything my calculator shows me. My calculator shows me 15.42584657. Of course, I don't have to write all that down if I'm rounding to 3 decimal places, because if I'm rounding to 3 decimal places, then I have to look at the 4th decimal place to determine what to do. If the next digit, in this case, would be 8, but if the next digit is less than 5, then you leave this alone and that's your answer. But if it's 5 or greater, then you round this up to the next whole number. So 425 would round up to 426 because the next digit is it's 5 or greater. So approximately 15.426. The wavy equal sign just means approximately because this is not equal to that, which is not equal to that. They are approximately equal to each other. Now that first exponent problem really didn't need any explaining if you know how to use your exponent button. But the second one might. By the way, all 3 of these are based off of homework questions you can find from 1 through 5. The second problem has the square root of 8 in the exponent, and that can cause a problem if you don't know how to use your calculator correctly. This is where having a display calculator like this, or most graphing calculators, in fact all graphing calculators are display calculators, having one of those can be advantageous here because you type exactly what you see. So 6 exponent. Now there is a little bit of finesse when you have chunkier exponents. The square root of 8 being a single term, I don't think needs parentheses here, but if you're not sure, you could always open up some parentheses. And then the square root of 8. Well, the square root is above the square button here on this calculator, so it's above the button, so I have to hit second first. So second square root. And if you'll notice, this is where knowing your calculator is important. This calculator, when I press the square root button, it automatically opens up a parentheses. So I'm going to type the 8. And I've got 2 open parentheses, so I should press 2 close. Now, this calculator is smart enough that if I press equals right now, it will automatically close the 2 open parentheses, but I don't like leaving them unclosed. So there's the one for the square roots radicand, and then there's the one I set up for the exponent, and I get 158.834236. So in a display calculator, pretty much you type what you see, be aware of extra parentheses as necessary. However, in a one-line calculator, you have to be a little more careful, because in a one-line calculator, there are certain buttons that will execute the moment you press them. The square root is one of them. For example, if I press square root right now, it's going to square root the 0. It won't do anything because the square root is 0, 0. But if I had like an 8 in there and I press square root, it's going to square root that. And I can square root that. And I can keep going and going. I wonder how small that will get. Looks like it's getting closer to 1. Okay, oh, there we go. It's actually not equal to 1. It's just close enough that it can't tell the difference. But I digress. If you want to put something like 6 to the square root of 8 power, if you want to put something like that into this calculator on the left, this calculator will square root a number the second you press the square root. So unlike the calculator on the right, where you have to type the square root button first and then the 8, the calculator on the left, you have to press the 8 before you press the square root button. So to get the same answer, I would start by pressing 6, then my exponent button, which is y to the x on this calculator. But if I press the square root button right now, it's going to square root the 6. I want it to square root 8, so I have to press 8 first, and then tell it to square root that, and then press equals to complete the calculation. And if you'll notice, I get the same answer I got here. So it is your responsibility to know how to use your particular calculator. I want to remind you that you should not be using your iPhone as a calculator on your test. Since we're rounding to 3 decimal places and the fourth one is just 2, we're not going to round up, so we're going to round to 158.834. 158.834. 158.834. Now, before we talk about this last one with this E, I want to walk back around and make sure the camera is focused. This is the second take of this video. When I came back after about 6 minutes, I noticed it was not in focus, and I was worried 6 minutes was unwatchable, so I had to start over. So what is up with this E? Well, it's a constant, but it's a number that shows up so common it gets its own name. You know a number like that already, pi. Yeah, most people know pi is about 3.14, but if somebody asks you what is pi, the correct answer is not 3.14, because first off, that's an approximation. The correct answer is, it's the ratio of the circle's circumference to its diameter. In other words, if you travel all the way around a circle and then divide it by the distance across, you'll always get pi every single time. So that's really what pi is, the ratio of any circle's circumference to its diameter. Since it's 3.14, that means it takes about 3 diameters to make a complete trip around the circle, and then a little bit more. But E is another number that shows up so frequently that it gets its own name. I'm going to briefly show you where it comes from, and this is mainly for those of you who are going into and beyond calculus. In calculus, there is a function that shows up many times that looks like this. F of x equals 1 plus 1 over x to the x power, which looks pretty innocuous. It's not technically an exponential function because although the exponent has an x, so does the base. But it does show up very often in natural phenomena. And again, if you take physics, engineering, or calculus, you're going to run across this. This actually has a horizontal asymptote. The horizontal asymptote of this is y equals e. I haven't told you what e equals yet. I should probably tell you that. I'm all over the place here. E is approximately 2.71828. 1828 459045. You don't have to remember that. In fact, I'll show you where to find it in your calculator in a moment. But it's the horizontal asymptote of this. Or if you were to put it in terms of approaches, as x approaches infinity, 1 plus 1 over x to the x power approaches a constant that's called e. So that's where it comes from. Now, as an algebra student, I'm not holding you accountable for this. As for those of you who are future calculus students, you will see this. So what do you need to know? Well, first you need to know that e is a constant, not a variable, and you need to know where it is in your calculator. I think I said this already in this video, but if your calculator doesn't have a log button and an ln button, over here on this one, you need to get one that does. Because if you notice above the ln button, it says e to the x power. Come on, focus, focus. There we go. The main reason is e to the x and ln are inverse functions, but we'll have that discussion later. So, how do you put a problem like e to the 1.2 power in your calculator? It depends upon whether it's a display or a one-line calculator. If you have a display calculator, the e to the power button is above the ln, so you have to press second to access it. This may have turned off. Let's clear that out. So second ln will bring e to a power, and if you notice, it already has an exponent sign and an open parentheses for me. How nice. And then I just have to press 1.2. I think I can press enter without closing the parentheses. Yes. This calculator will not give me an error message, some will. So again, in a display calculator, you pretty much type exactly what you see, maybe with some extra parentheses. But in a one-line calculator, come back, in a one-line calculator, e to the x, which is also above the ln button, is another button that will execute the moment you press it. In fact, any button that only requires one value to do something in a one-line calculator will execute the moment you press it. That includes square root, squaring, reciprocal, e to the x, 10 to the x, log, and ln. We'll talk about those in the next videos, next series of videos. These guys are all trigonometry functions, but they also only require one input. So in a one-line calculator, when you raise e to a power, you have to put the power in first. So if I want to do e to the 1.2 power, I first have to press 1.2. Then I have to do e to the x, which is in green above this one, so I'll press the green button first. Second, e to the x. And it gives me the same answer that I got over here. So it's your responsibility to have a calculator that can do e to a power and know how to use it. I'm going to go write the answer up on the board just so that it's complete. We are still rounding to 3 decimal places. Everything my calculator shows me is 3.320116923. But since we're only rounding to 3 decimal places and the fourth one is less than 5, we don't round up, so we round down and get 3.320. I'm going to close this video with showing you one more thing. I told you that your calculator knows what e is equal to because it can raise e to any power. So let's use this one. Focus. So how can you figure out what e equals to in a calculator like this? You just ask you what e to the first power is. And there it is. Hey, I know more digits of e than my calculator does. Yay me.